So some of the properties we have for kites, these two deal with the angles that we get when we draw the diagonals. The first one is the diagonals of a kite are perpendicular, and that's identical to the property we had for the rhombus, remember? And then the other one is the diagonal that splits the congruent sides of a kite bisects the opposite angle. So only one of the diagonals will this work, but that's also similar to the rhombus. Remember, the rhombus, the two diagonals, the diagonals bisected the opposite angles. Well, here only one of the angles does, and it's the angle that kind of connects the two vertices, the 2 points that are in between the congruent pieces. All right, and we'll kind of look at that a little bit more in a second here. So taking a look at something like this guy, first of all, the very first property we have here is that the diagonals are perpendicular. That one's an easy one to identify. We say, okay, the diagonals are perpendicular, so that means this guy right here is a right angle. In fact, it means all of these in here are right angles. So I have 4 right angles where those diagonals come together. And really, right away, that gives me angle 1. So let's talk about angle 1 as 90 degrees. Okay? From here, once again, just like many of our other shapes, as I start to draw these diagonals, it splits this thing into a bunch of triangles. And so if I were to kind of look at maybe this triangle right here, okay, I'm highlighting in green, the one that has angle 2 in it, all right? If I were to kind of draw that up to the side real quickly, right away I know that that's a 90-degree angle. Remember, that's the perpendicular property, that the diagonals are perpendicular to one another. And then from here, I also know that this angle up here is 45 degrees. So really all I need to do is find that missing angle. To find that missing angle, I say, hey, the 3 angles inside a triangle add up to 180. I already have 135 degrees. So I just need to subtract and find what's left. Well, it's another 45-degree angle. So this one's also 45 degrees. Okay? So the measure of angle 2, that's going to be 45 degrees. And now going towards something like the measure of angle 3, if I kind of pop back out of here, let me erase this triangle that I've been dealing with. If I were to draw the other triangle that's on this side, I already established this is a right angle. But if I were to draw this bigger triangle, kind of thinking about this guy, that bigger triangle, those 3 angles also have to add up to 180 degrees. And this one, I guess I don't need to write off to the side. It's big enough that I can write inside here. But right away, I already have these 2 angles, giving me a total of 155. So it's just a matter of subtracting to get the third angle. It's going to be a 25 degrees. So right here, this is a 25-degree angle. And this is where that second property comes in. That second property says that, hey, the diagonal that splits the congruent sides. And so I need to identify which diagonal that is. And so when I look at that, for this particular example, it's that longer-looking diagonal. So this one right here, okay? That one splits the congruent sides. When we look at right here, it goes in the middle of these 2 sides. And it also goes in the middle of these 2 sides. And so that's what I mean by splitting the congruent sides. So we're looking for that particular diagonal because only that diagonal will bisect the opposite angles. Notice the other diagonal, this one right here, that doesn't bisect the opposite angles. Here's a pair of angles over there. And notice it doesn't cut that in half. Those are not the same. It's only the diagonal that splits the opposite sides. And so when I look at that, that means that these 2 angles over here, angle 2 and that other angle, they're both the same. It also means that these 2 angles over here are also the same. Okay? So the measure of angle 3 is also 25 degrees. And now from here, once again, I have another triangle. If I kind of look at this triangle down here, look, there's a 90-degree angle here. There's a 25-degree angle here, which means that missing angle, it's the same as the triangle I just dealt with. Look, right here, 25, 90, and the third one's 65. So here, 25, 90. Well, this third one's got to be 65 as well, okay? So measure angle 4 is 65 degrees, okay? If I look at the next one, once again, as I look at this thing, right away, they come together at a 90-degree angle. The diagonals are perpendicular, so that's the measure of angle 1. Once again, I have these 2 angles right here, give me a total of 142. And the 3 angles inside a triangle add up to 180. So once again, I can subtract and get a 38 degrees. That's the measure of angle 2. And then angle 3, Once again, I have to identify the diagonals here. The diagonal that splits the congruent sides is this guy. So this is the diagonal that splits the congruent sides. So that means it also bisects those angles. So right here, these two angles must be the same because that's the diagonal that bisects the angles over there. Okay, so angle 3 is also 52 degrees. Okay.